A television box carries a row of familiar performance badges: HDMI 2.1, 4K, 120 Hz, variable refresh rate. A gaming console carries a matching set. The cable packaging between them reads ultra high speed. Everything aligns on paper. Plug in, power on, and the display's source list shows the console connected at a standard refresh rate, with variable refresh inactive, and high dynamic range grayed out. The badges matched. The feature did not arrive. HDMI became the default connector in living rooms. One cable replaced a tangle of component and composite connections that had cluttered every entertainment shelf for a decade. The promise felt complete. As resolutions climbed and frame rates increased, bandwidth became the hidden constraint. Higher resolution and higher refresh rate together consume more link capacity, and every port generation has a ceiling. A cable labeled ultra high speed on braided jacket packaging meets one bandwidth tier. A cable from an older generation meets a lower tier. The version label HDMI 2.1 references a specification that includes several higher bandwidth modes and a catalog of features, and each feature in that catalog is listed as optional for manufacturers to implement. A television manufacturer can print the version number on the spec sheet sticker and implement only a subset of those features. One port on a given television input panel might support the higher bandwidth mode. Another port on the same panel might not. The tiny printed labels beside each HDMI socket rarely spell out which features that specific port carries. The spec table printed in the manual, a grid of ports, resolutions, refresh limits, and supported features, sometimes clarifies, sometimes omits, and sometimes contradicts the box. Variable refresh rate, a feature that makes motion smoother by synchronizing the display to the source frame by frame, became one of the most visible casualties of this optional structure. A console box showing a variable refresh rate badge as a marketing icon implies the feature will work on connection. A television carrying the same badge implies it will respond. The actual behavior depends on a handshake, an electronic negotiation where the display reports its capabilities to the source device, and both agree on a shared mode. If the television's specific HDMI port lacks the bandwidth mode required, or if the firmware limits the feature to certain resolution and refresh combinations, the handshake settles on a lower common denominator. The badge on both boxes told the truth about the specification. It told nothing about the specific port, the specific mode, or the specific firmware state. High dynamic range follows the same pattern. A badge on the box, a capability that depends on bandwidth, port implementation, and cable generation. Final image quality is the intersection of every link in the chain, and the retail shelf tag compresses that entire chain into a single icon. The resolution naming layer adds its own friction. 4K on a television box typically references a horizontal pixel count near 4,000. QHD on a monitor spec card references a different resolution, roughly 2,500 pixels across, sometimes marketed as 2K, even though cinema's original 2K referred to yet another count. UHD on a label on a box corner sometimes matches 4K, sometimes serves as a broader branding term. A single number means different things on a monitor stand base versus a television shipping carton versus a projector feature list. Search for 2K resolution, and the answers conflict depending on whether the source is a cinema standards body, a monitor manufacturer's spec card, or a retail shelf tag. The naming feels precise. The mapping is not. Returns and support calls became the enforcement layer the standard itself lacked. A return receipt with an HDMI cable line item processed at a customer service counter beneath an exchange policy placard represents a cost absorbed by the retailer for confusion created upstream. Firmware update note cards shipped inside television boxes acknowledge that features may arrive after purchase. Support page troubleshooting checklist headings walk through no signal messages, black screens, and complaints that colors look wrong. These are symptoms of a handshake that settled below expectations. In the PC ecosystem, capability tends to be exposed more directly. A graphics card box spec sticker typically lists bandwidth tier, supported resolutions, and refresh ceilings tied to specific output modes. Monitor manufacturers publish detailed spec tables linking each DisplayPort input to precise resolution and refresh combinations. The mapping from port to behavior is often clearer than in living room HDMI marketing, though DisplayPort carries its own version complexity. PC buyers compare spec tables before purchase. Television buyers compare a cluster of feature labels that promise more than they explain. Standards bodies responded with certification layers. Cable categories with names like ultra-high speed now replace version numbers as the consumer-facing label. Some manufacturers list features per port rather than per device, and the direction is toward naming capabilities directly and certifying the cables that carry them. Informed buyers have learned to look past the version number on the television input panel and check whether a specific port supports the feature they care about. A version number compresses a matrix of optional features into a single identifier. A resolution name compresses a pixel geometry into a marketing term that shifts meaning across product categories. A row of small logos compresses a negotiation outcome into an icon. Each compression loses the conditional. A television still carries a row of badges. A console still carries a matching set. The cable between them still reads ultra high speed. Whether the feature arrives depends on which port, which cable tier, which firmware, and which handshake. The badges describe a specification. The living room delivers a negotiation. They have never been the same thing.